what I want to see, as soon as I say Gauss-Jordan, even if you're using a calculator, you should write down your augmented matrix somewhere on the problem. So the augmented matrix for this one is going to be 1, -3, and 11. And then we'll have a 2, a 1, and a 1. And then basically all you're going to do is you're going to plug that in your calculator. And the big button we have to remember is that RREF, that row reduced echelon form. That's your major button that you're going to hit to actually do it. So what we're going to do is we're going to plug this in our calculator. Whatever we get out, we're going to put here, and then we'll put what that means. For anyone that has a TI Inspire, Ross, I think that's you, right? Oh, okay. Matrices are all in your menu button. There's a menu button somewhere on there. And then you can scroll down and get to matrix. And it's the same ideas. You just put the size of your matrix in, and then you're going to be able to go to the matrix button, and there actually is a row reduced echelon form button. Yeah. That's where you're going to create a matrix. What was that? That's saying what you're trying to do. So you want to create a matrix first. There you go. Oh. So in this one, we are going to create a 2x3 along with you guys. So that would be here. I should have my Wabbit up. There it is. Remember, your matrix button is right here. It's that second matrix. And we're always going to go to edit. If I hit enter, you're just going to have a shootout back at you, which you don't want to have happen. You want to go ahead and edit it. Now we want a 2x3. And then I'll go ahead and enter my numbers. That would be a 1, a -3, ooh, a 2, a 2. Oh, no, I'm plugging in the wrong one. I should have a 1, -3, and 11. That's the problem we're on. That's still a 1, though. Typing on this is hard. And then we have 2, 1, 1. All right. So that is my augmented matrix. The only difference here is your calculator doesn't care it's an augmented matrix. It's just a 2x3 matrix according to your calculator. Now, a good idea is hit second, quit back out of that. And then you're going to go back into your matrix, and you're going to go to your math button, and you're going to scroll probably up is faster, or if you remember the number, but we're going to scroll until we get to that RREF. I'm going to go ahead and hit enter. Then I'm going to go ahead and hit matrix A. I'm going to go ahead and hit enter, and it pops up with 1, 0, 0, 1, and then 2, -3 on my augmented matrix portion. Any questions on any of those steps that I did? Yeah.
Why does this have parentheses around it?
Because we all have different, this is the TI-84 plus silver edition, so depending on what edition you...
Oh, mine's a silver edition.
Oh.
My old one is though.
Depending on the stuff you have and whether you actually put parentheses around the whole thing. I didn't end this with parentheses. Depending on a bunch of things, and your calculator is going to depend on how it spits out. But the end result is this is your matrix. That is your matrix 1, 0, 0, 1, and your augmented portion is that 2, -3. So this is what I expect on your handwritten results. That you should write your 1, 0, 0, 1, and then it was 2, -3. And then you should say x equals 2, y equals -3, and that's all I expect handwork-wise. So you should write your initial matrix, what your calculator spit out, and what that actually means. Don't make me interpret your answer, because I'll interpret it wrong every single time. All right, now we're going to get into something new. Well, not new, because we did this yesterday using inverses, but we didn't talk about using our calculator to do inverses. When using inverses, just remember that what's actually happening is we're turning this into a series of matrices where we have 1, -3, 2, 1, and we're multiplying that by x, y, and that's going to equal 11, 1. But that's not what we're plugging into our calculator. We're not going to type all that into different matrices and plug it all in our calculator. In fact, we're just worried about that inverse. We're just worried about the inverse of this function, or this matrix, being multiplied by these numbers, and that will give us our result. So our work is really, in our calculator, well, we're not going to have the x and y, but we should have it down here. But x and y actually equals our matrix 1, negative 3, 2, 1, and we're going to find the inverse of that. Then we're going to multiply that by that 11, 1. So we just need to, in our calculator, type two matrices, two different matrices. So we'll be in matrix A and matrix B. Matrix A, I'm going to make a 2 by 2 matrix, and I'm going to put these numbers in. Matrix B, I'm going to make a 2 by 1 matrix and put these in. So that's exactly what we're going to do. We're going to go back over to our calculator. We're going to go back to our matrix. We are going to edit,
Did you say y equals 11, 1 divided by the other matrix?
No.
Oh,
Inverse. That's the inverse symbol. It is multiplication. I guess you could put a multiplication symbol there. If there's no multiplication symbol, you assume it's multiplication, and it is a multiplication. All right. So let's go back. Let's make this a 2 by 2 matrix. And just put that coefficient matrix in. So that's going to be that 1, negative 3, 2, and 1. So in fact, when I made it that 2 by 2, it actually left it cut out the augmented portion of it and left me with that 1, negative 3, 2, and 1. Then what I want to do is I do want to back out, because sometimes I'll put, if I hit the matrix button again, I'll try to put everything in there. Then I'm going to go back to my matrix, and I'm going to go down to B, because I need to have two matrices to do the inverse. So I'm going to edit B, and that is going to be a 2 by 1 matrix where we have 11 and 1. I'm going to pause for just a second so everyone's there. The one good thing about this method is it's, as long as you remember what inverses are, it's easy to remember how to use your calculator for it. The problem with the augmented matrix is you have to remember that RREF. And it seems like it's going to be super easy to remember, but 2 months from now, when you forget, that's when this one kind of comes in handy. Because what you're going to do is we're going to back out. We're going to go to our matrix, and then we're actually just going to hit A. So A is that 2 by 2 matrix right now. Now I want the inverse of A. The inverse button is actually our matrix button without hitting that blue button. So you're just going to hit this x to the negative 1 button. And then you're going to hit times. We're going to go back to our matrix, and I'll multiply that by my B. And that is going to spit out with 2, negative 3. So when I go back here, this is just going to equal 2, negative 3. That's what my calculator spit out. And just read the results to me. X equals 2, y equals a negative 3. And that's all you need to do the inverse in your calculator. Questions on that? All right, if you look at your homework calls for you to, on the first 4 problems, you're supposed to do it by hand using the method indicated. So like the first one's Gaussian, the next 2 are using inverses, and then that last one, number 4, is using Gaussian. For number 5, 6, 7, 8, you're using your calculator. You need to solve it using both ways. So you should have notes on how you did your Gaussian augmented matrix and what your calculator spit out. And on the other side, you should basically have your matrix. And let me just kind of, this is all I need to see for the inverse. Because I don't need to know what your inverse function is because your calculator is going to bury that all in there. All I need you to write is your coefficient matrix say that you're taking the inverse of it and you're multiplying it by your 11 over 1. So this is, in fact, all of the work you need to show for your calculator for inverses. This is all the work you need to show for your Gaussian elimination ones. But you have to know what to write, because on the test, like I said, I'm going to say make sure you do the inverse and make sure you write down your work saying you're doing the inverse. If you just popped out an answer, to me that means that you didn't know how to do the inverse and you just used Gaussian and you just didn't want to show that you didn't know how to do it on your calculator. All right, so know both directions and what I expect written-wise. All right, that being said, what questions we have from the homework? I do want to preface that with number 48, copied very lightly. The answer was 3, negative 1 over 2. If you knew that, you could look really closely at it, and it wasn't a 3 down there, it was a 2 down there. So number 48 should be 3, negative 1/2. Yes?
In 58, on the answer key, it said that when you make the inverse, wait, yeah, the 3 becomes negative, but it's already negative.
So it is already negative. Yes, I agree. So let me take a picture real quick. I agree with your logic. I disagree with your conclusion. So my original matrix is 2, negative 3, negative 1, 1, right? When we find our matrix inverse, we switch these two, and we change both of these signs. So that becomes a positive 3 and a positive 1. But we are dividing them all by negative 1. So in fact, they'll all become negative. Does that make sense? Yeah. All right, awesome. Other questions? Yeah, Mary.
Number 45.
Which one's number 45? 45. Did you have a specific question of what I did, I guess?
I just got something totally off.
So do you think you're okay if I take the picture of it and we just walk through it together? Would that be fine? All right, we'll find things. So your original matrix, right, is 1, 6, 1, 9?
Yeah.
Okay, and did you find your determinant being 3? That. Yep. What did I say on the day 1? Everyone's going to add them at some point. Everyone's going to do it. Just hopefully you don't do it on the test. Yeah.
I got a really different answer for 51. I can see what it was.
Okay. Let's just start 51 then. So 51. Yeah, I guess I'll just write it. So 51 was, you should have got a matrix that looks like 1, negative 5, negative 1, and 3, right? That's your matrix? Yeah. So that's my matrix M. Let's call it M. Now let's go ahead and find our determinant. Our determinant is going to equal 3 times 1, which is 3, minus negative 5 times a negative 1, which is a positive 5. So it's 3 minus 5, which gives me a negative 2. Was your determinant negative 2?
No. So.
That's probably the, yeah. Okay. So that might be as far as I need to go on that one. Yeah.
You can go with that one.
Sure. Do you got a determinant of negative 2? Okay. So our inverse, sometimes our inverse, especially if you start messing them up, is easy if you just write, 3 and 1 and then put them over there negative 2. Then we're going to change the sign. So instead of a negative 5, we have a positive 5.
Oh, sorry.
Over a negative 2, and we'd have a positive 1 over a negative 2.
Never switch the A and the B.
Yep. Or the B and, okay. Oh, you left it as 1 up there and 3 down there. Yep.
And then affected everything.
Yep. That will do it. What? What? Quit laughing at me. This isn't a funny class. Everything I do, I'm serious. Are there other questions? All right. Then I just wait for Ross. As long as Ross says no, or he speaks for the class. he takes a poll quickly of everyone, and it's like, nope, everyone's good. All right, guys. The rest of the time is yours to work. I will walk around and I will check your homework. Tomorrow, as you